Hello students, welcome back to my YouTube channel. This is Kashima Soni and today we are going to take up our next topic in the series of carboxylic acid derivative, that is your part 2 of acid anhydride. See, we have discussed still the physical properties of acid anhydride in the part 1 of your this particular derivative, that is acid anhydride. Today we are going to talk about chemical properties of acid anhydride. But before that, I would like to make a request to all of you. Just go through all the links that I mentioned in the description box. Just check that wisely and then switch to this part. Okay, because you are not going to understand anything that I'm going to discuss in this particular series if you are not going to check the previous videos that I have uploaded in this particular chapter. Correct. So go over there, check that wisely and then switch to this part. Alright. So proceeding further. Okay, that we have already taken in the previous video. I'll just switch to the chemical properties. Correct. So yeah, that is this. Okay, so we are going to discuss three reactions, that three nucleophilic acyl substitution reactions. The first one is going to be your hydrolysis reaction. Another one is your alcoholysis. And third one would be ammonolysis, just like the previous one. Okay. And sorry, it is not going to be acid chloride. Over here you can mention acid anhydride. Okay. This is going to be your second most reactive acid derivative after acid chloride. Okay. So we are going to take up the three reactions. The first one going to be hydrolysis. Okay. Always remember that, that your acid anhydrides, any of your acid derivative upon hydrolysis, they are going to give you back your carboxylic acid. Understanding? So on reaction with water, you can see it is giving back your 2 molecules of acetic acid. Correct. So this is one reaction. Let's see the general mechanism for the same. Okay, so this is the mechanism of your anhydride hydrolysis. Over here you can see in the first step what is occurring. Nucleophilic addition. How? See, oxygen is accepting an electron from this pi bond and thereby making this carbon susceptible to get attacked by the nucleophile water. Okay, so you can see how your nucleophile water is attacking this carbon. Okay, now it result in this in the formation of this particular structure. And now what will happen in this particular structure, just open it up like that you can write. Okay, it is R and it is like this. Okay, over here it is oxygen negative and this oxygen is carrying positive charge. See, I have already told you that your oxygen, being electronegative in nature, will always try to retain its electronegativity. Correct. So how it will retain its electronegativity? By accepting a pair of electron by accepting electron from this particular bond. Okay, from this particular sigma bond. Okay, now what will happen? There will be occurring proton transfer like that. Okay, so this is the step, this is your second step in which it is occurring, proton transfer. Correct, which leads to the structure like this. Correct. Now in the next step what is happening is your expulsion of your carboxylate anion. Okay, expulsion, or you can write like this, expulsion of carboxylate anion. Correct. So this is one thing. After expulsion, how you are going to see the expulsion of carboxylate anion? See, from this particular lone pair of electrons of oxygen, these are going to go back to this sigma bond. Okay, and then this electron, this bond will get shifted to this oxygen, and electron from this bond will get shifted to oxygen, thereby resulting in the release of your this carboxylate anion. And after that, the structure that is left is this. Correct. So now what is happening is, since oxygen is donating its lone pair of electron to this particular sigma bond, so now it will be carrying positive charge as it is shown over here. Correct. Now the carboxylate ion which is left out in this particular previous step, that is in your third step, will be acting as a sort of your nucleophile, and it will abstract the base from here like that, and it will result in the formation of your this particular structure. Okay, so that is how you are going to see the formation of your carboxylic acid from your anhydride via hydrolysis mechanism. Correct. So this is the first reaction. Second is your alcoholysis, the conversion to esters. See, your acid anhydride, being more reactive, can also get converted to your esters as well. So this is your acid anhydride, when reacting with alcohol in the presence of a base, that is pyridine, will result in the formation of a ester and carboxylic acid as well. So this is another reaction. whose mechanism we will see over here. See, I've already told you oxygen will be accepting the electron. First step will remain same. Oxygen will be accepting electron from this pi bond over here, and thereby making this carbon susceptible to get attacked by this your nucleophile. That is nucleophile over here is alcohol. Okay, correct. So it leads to the structure like this. Now, what is happening? This pyridine will acting as a base will abstract this proton over here and will result in this structure. Correct. And after this structure, we will be doing the same step as we have done in the previous hydrolysis mechanism. We will be expelling the carboxylate anion like that. Similarly, and we will get our product, main product, that is ester, and the side products will be this. So this is how you are going to see the reaction of your anhydride with alcohols. Okay, so that is your ammonolysis. See what is happening over here, the conversion to amides. Ammonia and both primary and secondary amine, they will react with acid anhydride to form acid amide. So you can see over here the reaction of acetic anhydride with ammonia. It results in the formation of your acetamide and acetic acid. So the main product is over here is going to be acetamide, and this is going to be your side product. Okay, and we have another example where your ethanoic anhydride is reacting with what? With ethanamine in the presence of a base pyridine, resulting in the structure like this, and side product acetic acid is obtained similarly. Okay, so we can see general mechanism of your reaction of anhydride with amine. What is happening? You can see this carbon being electrophilic will get attacked by this nucleophile over here, and what it will result in the structure like this. Now what is happening? Nitrogen being electronegative will try to retain its electronegativity by accepting a pair of accepting electron from this particular sigma bond. Correct. And what will happen? This RNH2 will be abstracting proton from here, and after that the product left out would be this particular structure. Now in the ending, this step will remain same, that is your third step, expulsion of carboxylate anion, which will give you your secondary amide and this side product as well. So the mechanism are same of your hydrolysis, of your alcoholysis and ammonolysis as well. This is not that much difficult, correct? So let's proceed to the other reactions of acid anhydride, that are your Friedel acylation, reaction with lithium aluminum hydride and dehydrating agent. So proceeding to the first reaction, that is, see, the first reaction that we are going to take is your Friedel-Claft acylation, that result in the conversion to aromatic ketones like that. You can see benzene is reacting with an acid anhydride, that is your acetic anhydride, in the presence of anhydrous AlCl3, resulting in the formation of your aromatic ketone, that is acetophenone. Okay, in the presence of Lewis acid anhydrous AlCl3, it is resulting in the formation of aromatic ketone, that is acetophenone over here, and the side product obtained is acetic acid. So that is how your Friedel-Claft reaction in case of your acidic anhydride will proceed. So that is also not difficult, correct? Proceeding further to the other reaction of acid anhydride. See what is happening over here is your anhydride on reduction with lithium aluminum hydride will be giving you primary alcohol. So you should always remember this thing, that your acid anhydride on reaction with LiAlH4 is going to give you primary alcohols. Okay, that is one thing to remember. So you can see this is your acid anhydride in reaction with the LiAlH4 in the presence of ether, and after getting hydrolyzed, it is going to give you your alcohol. Okay, but in case of mixed anhydride, two different primary alcohols are obtained. That is quite understandable. See, if your this R group is different and this R dash group is different, what is happening? You are definitely going to get primary alcohol, but two different primary alcohols are obtained. Okay, so that is quite understandable, correct? And another reaction would be your dehydrating agent, where your acetic anhydride, it can act as a dehydrating agent. Okay, you should always remember that your acidic anhydride is going to act as a dehydrating agent. You can see over here. See, higher acidic anhydride can be prepared by heating the acid with acetic anhydride or some other dehydrating agent such as phosphorus pentoxide, that is P4O10. Okay, so what you will do, your higher acid can be your higher acidic anhydride can be prepared by heating the higher acid with acetic anhydride. This will result in this particular higher anhydride, higher acid anhydride, and also your side product acetic acid is released. I repeat, what is happening in the dehydrating agent is acetic anhydride over here in this particular reaction is going to act as a dehydrating agent. Correct? Your higher acid is reacting with acetic anhydride so as to give you your higher acid anhydride, and side product acetic acid is obtained. So that is all about these reactions. So far we have discussed the hydrolysis, alcoholysis, ammonolysis reaction of your acid anhydride. Then we have taken the your other reactions as well. So that were not that difficult. The mechanism was also same. So I have tried to cover it in this shorter video as easily as possible. And if it is quite faster, if the video is quite faster, I request you to play it in the slow playback speed. You can keep it as, at slower motion so that you can easily understand the concept as well. If I'm being faster right now. And yeah, that's all about it. If you have any sort of issues, you can mention it in the comment section. I'll take it up as soon as possible. And that's all about this particular topic, this particular derivative, that is your acid anhydride. In the next series, in the next video, I'll be coming up with another acid derivative, that is your ester. Okay, and I'll be taking every topic related to your esters, that is physical as well as chemical properties. So that is all about it, and I request you to kindly go check out the links I have mentioned in the description box. So that's all about it. Thank you. Do watch, do subscribe, and do shower your love. Yeah, thank you.